All right, guys, so in this video, we're going to be talking about shifts of functions. And so one of the things that we want to make note of is our vocabulary section right here. Again, this is going to be a topic that you should be already familiar with, so I would expect that this would just be a quick review. All right, so here we are given function f of x. A new function g of x is basically taking that f of x function and adding k to it, where k is a constant. Remember, a constant is a number without a variable, and that is going to represent a vertical shift of the function. All of the output values are changed by k units, okay? So all of the y values are going to be affected by that. If k is positive, the graph is going to shift up. If k is negative, the graph is going to shift down. So let's take a look at problem number 1. It says here, to regulate temperature in a green building, airflow vents near the roof open and close throughout the day. The graph shows the area of open vents V throughout the day in hours after midnight, which is represented by the letter T. During the summer, the manager decides to try and better regulate temperature by increasing the amount of open vents by 20 throughout the day and night. Sketch a graph of this new function. Okay, so the idea here is we had our original function, which is in blue, and then we are moving it up 20 units. So this would be 20, this would be 220 right here. So we're moving that portion up. Let's call that, I don't know, what do we want to call this? Maybe 240. All right, let's say that that's 240. And this is 20. So what the graph is going to look like now is every point is shifted up, okay? And then this is going to also shift up here and here. And so these are here. This is here to here. And then we can kind of just like trace it like that. So noticing that vertical shifts can move up or down. All right, now from a table perspective, we are given the function f of x in this table. Create a table for the function g of x, which is saying take the f of x function, or take the f function, and subtract 3. So you're moving it down 3. So our x values are going to stay the same. It's just that we are now going to be subtracting 3 to every y value. And so these are going to be our new y values on this new g of x function. Okay. Now, horizontal is going to move left and right. Let me do a different color for this one. So horizontally, we're going to be moving left and right. And we have the same kind of situation. It says, returning to our building airflow, suppose that in autumn, the facilities manager decides that the original venting plan starts too late and wants to begin the entire venting program 2 hours earlier. All right, so what is that going to look like? We want to sketch a graph of the new function. All right, so if we're starting 2 hours earlier, we would be moving everything to the left 2 units. All right, so instead of 8 hours after midnight, we would be at 6 hours after midnight. So maybe from here, and even though at 0, we're going to move it over to -2 just to have the graph. And then here we're moving it over to the left 2. Here we're moving it over to the left 2. And of course here we're moving it over to the left 2. I just wanted to show you that here. We're not moving anything up or down. We are just moving everything to the left by 2 units. And so you can see that on our purple graph, we were able to just move everything to the left. Okay. All right, now from a table, this can kind of look a little intimidating, but I want you to think about the idea behind horizontal changes. Okay, so what you are trying to do with horizontal changes, horizontal is going to affect the input. Okay, so your input, which would be inside the parentheses. All right, so this is what we do. We are looking at something and we are trying to figure out how to take it back to f of x. So what would we have to do in this problem right here, f of x minus 3? In order to get this back to looking like f of x, we would have to add 3. So that way we would be able to get rid of these and get back to x. So that's essentially what you are doing. You are going to be adding 3 to these x values to generate your new x table. Okay, so if I have 2 plus 3, well, that means my x value is going to be 5. This is going to be 4 plus 3, which is 7, then 9, then 11. All right, and then this right here, we can usually like bypass this, but they're just showing you what's happening here. If you were to take 5 minus 3, that's going to give you 2. And then your y value, because remember if it says f of this, that's going to indicate the y. So this is going to be the y table. So this is going to be a 1, this is going to be a 3, this is going to be a 7, and 11. And just think about that. If you were to plug in 5 minus 3, you get 2. And then that means you would come back over here to the original table at 2, and your f of x would be 1. Same thing with 7. 7 minus 3 would be 4, and your f of x function would be 3. And so we notice that the x is the only thing that changes. Your y's are the things that stay the same. And so your g of x is also going to stay the same. The g of x is just the y values. All you're doing is affecting the x.